Okay, today we're going to take a look at applying deductive reasoning. So we're going to talk about what is inductive reasoning, what is deductive reasoning. Then we're going to talk about the different forms or different kinds of deductive reasoning. So inductive reasoning is just reasoning based on a pattern. We do it all the time without even thinking about it. So we use specific examples and you observe them and you make a decision based on that. So for example, what are the next two numbers in that pattern? If you look at that, we're going -3, 5, -7, 9, -11. So we're going with odd numbers, so we can infer that it's going to go to 13, 15, and then every other is odd. So those would be our next two numbers. So we looked at a pattern and we made a decision. Okay. If you have homework every night, will you have homework tonight? Based on that pattern, absolutely you will. Now remember though that sometimes those patterns won't hold, right? Maybe we're not going to have homework tonight. So you can disprove that conjecture with a counterexample, and we talked about those earlier when we talked about conditional statements, and you can disprove it by finding a counterexample. Okay, so deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. So this is more formal kind of proof, okay, more formal kind of reasoning. So for example, if all men are mortal and Mr. Harris is a man, therefore Mr. Harris is mortal, okay? So that is based on accepted properties. All men are mortal, Mr. Harris is a man, therefore he's mortal. To get an A in geometry, you need to get at least a 90%. You have an A in geometry, therefore you have at least a 90%. Okay. Those are examples of deductive reasoning. Okay, it's different from inductive reasoning because it uses specific examples and pattern. Inductive reasoning does. Deductive uses the laws and properties that we have learned. So one of the rules for deductive reasoning is the law of detachment. And what the law of detachment says is if the hypothesis of a true conditional statement is true, then the conclusion is also true. Okay. So if P is Q, if PQ is true, P is true, and then Q is also true. Okay. Might not look like much right there. Okay, some examples of law of detachment. So hopefully this will help you make sense of it. If today is Halloween, then you wear a costume. Today is Halloween. Okay. You can make a Venn diagram to show this. And a Venn diagram for law of detachment is going to look like this. Your hypothesis is going to be in here. So that's Halloween. I couldn't really spell it all on there. And then wearing a costume is going to be in here. Okay. So when you go to decide if you can make a valid conclusion or make a conclusion with this, you want to look at two things. You want to look at your hypothesis, and then you want to look at the statement, the thing that you're trying to use to make a conclusion. So this says, if today is Halloween, then you wear a costume, and today is Halloween. These have to be the same in order to make a conclusion, okay? So today is Halloween. Those match. So the conclusion we can make is you will wear a costume. So this is today. Today is Halloween. So you're going to wear a costume, and it falls into that Venn diagram like that. Now, here it says if you want a steak that is grilled to perfection, then you go to Morton's. Okay, Brandon went to Morton's. So if we make our Venn diagram here, this is a perfect steak, and this is Morton's. So we look at the hypothesis and our statement here. Notice that they don't match. If you want a steak that is grilled to perfection is our hypothesis, and then Brandon went to Morton's is the statement that we're trying to decide if you can make a conclusion. And in this case, we can't because they don't match. So Brandon would fall in here and not necessarily in his perfect steak. So we can't make a conclusion. There's no valid conclusion. The law of syllogism. Okay. If the hypothesis P, then the conclusion R is true. And the hypothesis Q, then the conclusion R is true. Then P and R is true. So what happens is we're taking out the middleman, right? So we call this transitive also reasoning. Just another name for it. So if our hypothesis P, then Q is true, and then Q, then R is true, then P and R, then R is true. Okay. So if Matthew is in geometry, then he will take calculus. So there's my first statement. If Matthew takes calculus, then he will take statistics. What conclusion will you make? We can get rid of the middleman, right? And our conclusion would be, if Matthew is in geometry, then he will take statistics. So this is going to be 3 embedded circles. So geometry, calculus, statistics. And so Matthew would be this little guy in here, and if he takes geometry, because he's totally in calculus, he's already going to take calculus. Because he's already in there, he's going to take statistics. It's a lot like the real number system where things were embedded, and once something was a natural number, it was also an integer, which was also a rational number. Okay. So if 2 angles are a linear pair, then they are supplementary. If 2 angles are supplementary, then their sum of their measures is 180. So once again, we're going to knock out the middleman and come up with if 2 angles are a linear pair, then their sum of their measures are 180. I've got 2 angles that are a linear pair, so I know that their sum is 180 degrees. So that's the law of syllogism. Okay, the contrapositive of a statement, remember we take our P and our Q and we negate them and reverse them. So if I have a statement that says, if I am not sick, then I will go to school. If you don't go to school, then the conclusion would be, I am sick. So we just switched them around and made the statement. And that's all there is to the law of contrapositive. So today we looked at the difference between inductive and deductive reasoning, where inductive uses a pattern, it's based on observations. Deductive is looking at the formal rules of logic, accepted properties, facts, and definitions to come up with the conclusion. And we looked at the laws of reasoning, the law of detachment, the law of syllogism, and the law of contrapositive. So have a math-tastic day.